Hi, welcome back. And we will start a new section, but before, look at the puzzle. And we have Garfield here helping us with this math puzzle. You can use each math symbol just once. And how can you make the equation true? So you have 4 slots, you have 4 math symbols, it's plus, minus, multiplication and division. And what is the combination or the right order that you have to arrange this to make the equation true? Think about it, and at the end of this section we're going to come with the solution for this puzzle. And we will work today on chapter 6, Rational Expressions, section 6.4, Dividing Polynomials, Long Division and Syntactic Division. The first objective is dividing a polynomial by a monomial. And when you are dividing a polynomial by a monomial, you divide each term in the polynomial by the monomial. So let's say you have a plus b divided by c. So you can split. You can write down a over c plus b over c, when c is going to be different of 0, right? And working on an example. Check this. Let's say we have the polynomial negative 12a cubed plus 36a minus 15. We want to divide this by 3a. So we can split. We can split all each term, like negative 12a cubed over 3a, then plus 36a over 3a minus 15 over 3a. That's how we do it. And let me just fix this. This is an a. The next step is simplification. So we will simplify each expression. We have negative 12. We can simplify 12 with 3, and we're going to have 12 divided by 3, 4. We can simplify this a with a exponent 3. 3 minus 1. And let me see, what else can you simplify? 36 divided by 3, 12. A with a. And 15 divided by 3, 5. The final answer, after all the simplifications, is 4 times a squared plus 12, nothing else, minus 5 over a. Okay? This is the result, the final answer. I forgot this negative sign here in front of 4 for the first example. Next, divide 10t exponent 4 minus 35t cubed plus 5t squared by 5t squared. Well, we're going to do the same thing. We're going to break down, we're going to split. So this is equals the first term 10t4 over 5t squared minus the next term 35 3t cubed over 5t squared, and the last term here is 5t squared over 5t squared. Cool, we can simplify. 10 with 5 is 2. This t squared we can simplify, can subtract from the exponent, minus 2. And 35 divided by 5 is 7. This we can subtract from the exponent. And 5t squared divided by 5t squared, we will have here 1. let's write down the result after all the simplifications is 2t squared minus 7t plus 1. Okay. This is going to be the answer after you work the division of each term and the simplification that are possible. Okay, now next example. Now we have a next objective, dividing a polynomial, objective number 2. Dividing a polynomial by a polynomial other than a monomial you need to use the long division technique that is similar to the process known as long division in dividing two numbers, which is reviewed on the next slide. On this slide, you will see the process of dividing a number 7,256 by another number 43, and this is the step-by-step that you can apply, that you usually use to divide a number manually, right? When you don't have a calculator. This is how we learn to do, and the result will show up here. This is the result of the division, and this is the remainder. The remainder, at the end, you can calculate the final answer, which is going to be the result of 168 plus 32, the remainder, divided by 43. We will use this long division in the same way on polynomials. As you can see from the previous example, there is a pattern: divide, multiply, subtract, bring down, and then repeat these steps again and again and again until you find the remainder. So we will divide now the polynomial 28x squared minus 23x minus 15 by the binomial 7x plus 3. The first step is to divide 28x to 7x, x squared, 28x squared, into 7x. And this is going to be 28 divided by 7, 4, x squared divided by x, x. Okay? After that, we multiply 4x by the whole binomial, 4x times 7x plus 3, and then we're going to have as a result 28x squared plus 12x, right? And subtract, you're going to subtract from the polynomial, the original polynomial, and the result is 28 minus 28, 0, 23 minus 12, negative 35x. And now we bring down negative 15, we have negative 35x minus 15. Repeat the same step as the first one. You can divide the first term of this polynomial here, negative 35x minus 15. You divide negative 35x by 7x, and this will be negative 5, right? Negative 35 divided by 7. Negative 5, x divided by x, 1, so negative 5. Multiply negative 5 by 7x plus 3, and then you have negative 5 times 7x, 35x, and negative 5 times 3, negative 15. Subtract, or you're gonna subtract this from the line on top, and negative is negative, positive, negative is negative, positive. And after you subtract, you're going to have 0 and 0. That means the answer for this division, this is the remainder. The remainder is going to be 0. And the exact answer for the division is 4x minus 5. There is no remainder. Okay, now let's check another example. And we have here 2x, the polynomial 4x squared minus 6x plus 8 that we will divide by 2x plus 7. And the first thing, we will divide 4x squared by 2x. The 4 divided by 2 is 2, x squared divided by x, x. Now multiply 2x by 2x plus 7, and then we will have 4x squared and 2x times 7 plus 14x. Subtract, you're going to subtract, and 4x squared minus 4x 0, negative 6x minus 14x, negative 20x, right? And bring down plus 8. Let's bring down plus 8. We will divide again. We will repeat the same step by step. Divide negative 20x by 2x, and if we divide negative 20x by 2x, we will have negative 20 divided by 2, negative 10, x divided by x1. Next step, multiply negative 10 by 2x, negative 20x, and 7 minus 70, right? You're going to subtract, so let's change the sign. If this is a negative, becomes a positive. This is a negative, becomes also a positive, because we are subtracting. Because this first is going to be 0, and the second one, positive 8 plus 70, positive 78. Well, positive 78 is going to be the remainder. There's nothing else to bring down. That's the remainder. This is the result of the division. The complete result of the division is going to be, let me write here, 2x minus 10 plus what? The remainder, 78 divided by 2x plus 7. And just open some space here. Yeah, this is the complete answer, the result of the long division we just have finished. Okay, now another example, and if you have a fraction like this, c squared plus 3c minus 2 over c plus 1, you can rewrite as a long division like this, and then you're going to have the polynomial c squared plus 3c minus 2 divided by c plus 1, and let's work this out. Let's follow this step by step. You have to divide first c squared by c, and you're going to have c as a result. Multiply c by c plus 1, so is c squared. Let me just in a little bit. C times c plus 1, c squared plus c. Now you will subtract, change the sign. This is minus, then you subtract c squared minus c squared 0, positive 3c minus c, positive 2c, right? Now the next thing, you're gonna bring down the minus 2, okay, bring down, and you're gonna divide first positive 2c by c plus 2. Multiply positive 2 by by c plus 1, and then you will have 2c plus 2, right? Subtract change the sign. This is the subtraction, this is the subtraction. It's negative 2c minus 2, positive 2c minus 2c, 0, negative 2 minus 2, negative 4. And this is the last thing we can do, because this is going to be the remainder, right? And the complete answer, the full answer to this division, let me show here on the bottom, is, and we found c plus 2 minus 4 divided by c plus 1. Okay, another long division that we performed. We followed this step by step and we found the answer. Now we have another example. On this example, divide y squared minus 5y plus 6 by y minus 2. So let's work here the long division, and so n y squared divided by y is going to be y. Now I'm going to multiply y by y minus 2, and then I have y squared minus 2y. Change the sign because this is a subtraction, so negative y squared, and this is a positive, 0, negative 5y plus 2y, negative 3y. Okay, bring the next one, the next term, 6, and now we're going to divide negative 3y by y, and this negative 3. Negative 3 times 3 times y minus 2, negative 3y plus 6, right? And we are subtracting, so we're going to change this sign. What's negative becomes positive, what's positive becomes negative, and this is negative 3y plus 3y, 0, positive 6 minus 6, 0. Remainder, 0. The result of this division, it doesn't have any remainder. The result is y minus 3. And very good. The next objective is to use syntactic division to divide a polynomial by a binomial. And the syntactic division, to find the quotient and remainder when a polynomial of the degree 1 or higher is divided by, and check this, x minus c. You have x the variable and c is a real number. There is a shortened version of the long division called syntactic division. It's more an algorithm or something simpler that you can use, but only and only if you have the division by something like that. It's a binomial that looks like this, x minus c, okay? And what you need to know about syntactic division is that it's a method that allows you to perform faster division, a faster operation, but only if you have the divisor as x minus c, this form, x minus c. And the case here is x minus 2, c is a real number. And you have to keep in mind that you can work this with long division as well. If for some reason you don't remember how to do the syntactic division, you can work this out with long division. The result is going to be the same. To work syntactic division, you need to have all the orders here. You have the variables and you need to have all the orders. You have x degree 3, x exponent 2, you have x exponent 1, and you have x exponent 0, which is 4 times 1, right? So x exponent 0. You have all the orders, all the variables with all the degrees. Okay, now I'm going to write each one of the coefficients. 3, negative 2, 5 or positive 5, and positive 4. Okay? And on this side here, I'm going to write C. X minus C is x minus 2, that means C equals to 2. And draw a line. Drop the first coefficient, drop here. You're going to multiply 3 by 2, 3 times 2, 6, and you write underneath the next coefficient. Now we're going to add negative 2 plus 6, 4, okay? Now we get this one. You repeat the same process, multiply it by 2, and write down underneath the next coefficient. 4 times 2, 8. If you write down, and now we're going to add 5 plus 8, 13. Now we get this 13, and repeat the process, 13 times 2, 26, and add 4 plus 26, 30. The result is, well, if this is x cubed, the result is going to be 3x squared plus the next coefficient, 4x, plus the next number, the next coefficient, 13, plus 13, plus, and this is the remainder, 30 over x minus 2. This is the answer. This is the result if you apply synthetic division to divide the polynomial 3x cubed minus 2x squared plus 5x plus 4 by x minus 2. See, it's fast, it's not difficult, you just need to know the step by step, and but remember, it's only applied if you have this kind of divisor, x minus c, where c is a real number. Okay? Now, next objective, using the remainder theorem to evaluate polynomials. Check this. If a polynomial px is divided by, again, x minus c, we need to have this form, x minus c, then the remainder is p of c. We make x equals c, plug in into the polynomial, we're going to find the remainder. Check this out. Use the remainder theorem in the synthetic division to find p of 4 of the polynomial. 4x 6 minus 25x cubed plus 35x4 plus 17x squared. Okay? And there's something quite wrong here, because this is x5, sorry, something wrong because it's x5, see? x5, x4, and then x3 is 0, x2 is 17, x exponent 1 is 0, and x exponent 0 is 0. Yeah, this is the synthetic division. You can apply, remember the previous example. Drop 4, multiply 4 by 4, 16, then add, and then repeat this process again and again and again and again. You will find the result. The remainder is 16. 16 is going to be the remainder if you apply synthetic division. And let's make sure we have the right remainder, or if the remainder theorem is working. So let's calculate p of 4. It needs to be equal to 16. Let's check. equals 4 times 4 exponent 6 minus 25 times x, and x is 4, exponent 5 plus 35x exponent 4 plus 17x 17 times 4 squared. Now we need a calculator, type this operation, and you're going to make sure that you type all the numbers right, all the exponents right, and you find the result as P of 4 equals 16. Yes. That means the remainder theorem works. Okay, now we reached the end of section 6.4, and let's try to solve this puzzle, this math puzzle. And you need to try a few combinations, and after a few choices, a few arrangements, you're gonna find this: 3 plus 2 divided by 1 equals to 3 times 2 minus 1. Now let's check. 3 plus 2, 5, divided by 1, 5, equals 3 times 2, 6, minus 1, 5. 5 equals 5. That means this is the right sequence. 3 plus 2 divided by 1 equals 3 times 2 minus 1. Or you can flip as well, it's the same thing, it's the same solution. Thank you for watching this video, and see you on the next section.